Welcome to 1-1 Day 2 worked examples. We are going to go through a few more. I'd like you to write them down in your notes as we go through them. The first one gives us a situation where they want us to add a point T that is collinear. So I've gone ahead and plotted those 2 points. I have point Q, which is right here, and I have point R, which is down here. We got R, and they want us to find another point on that line. Well, one of the easiest things to do would be to calculate the slope. So if we remember from our 8th grade vocabulary, slope is considered rise over run, and we would need to then calculate that rise over run to see the slope, to see if we can find maybe another point on that line. Just to help us though, I'm going to just draw in a dashed line to kind of get an idea of what that line could look like. And then we're going to go ahead and see if we could calculate that rise and run value. So here our rise is starting down here, and this happens to be -4, and it is going to go all the way up to +4, so that is going to give me a rise of 8. Next, we're going to look at the run, and I'm out here at 4, and I'm going to go all the way backwards to -2. So 4 to -2 gives me a value of 6. So if I look at that slope from left to right, I read that slope as decreasing, so this would be a slope of rise -8 over 6, which would give me a value, if I reduce this, -4 over 3. So to find another point on that line, what we would do is just to start at either point Q or point R and do the slope in that direction according to what we just found right here, which is this is supposed to be a 4. So let's start with this one. If I wanted to follow that slope, I would have to go up 4, and then I would go backwards 3. So I'll change colors here to make sure we get a nice point. So up 4. We'll go with the cursor up 4, and then backwards 3. 1, 2, 3. It looks to be at this point right here. And it appears if I even started from this other point here, if I went forward 3 and down 6, I'd still be at that same point. So our point T is going to be at the point 1, 0. So move on to the next one. Choose the best diagram for the given relationship. Plane D contains lines script A, script M, and line T. So we have to have 3 lines with all of them intersecting at point Z. So let's just see if we can get some of these ones crossed off, because they're definitely wrong. So they have to meet at point Z. So I'm going to say definitely this one here is wrong because they're meeting at point F. So they all tell us here that they all contain, the plane contains all of the lines. So I notice here that this line here, A, is not actually in the plane, so this one is going to be definitely a no. And let's see what else we know. F. F is on the plane but is not collinear. So looks like this F value is collinear, so our correct only answer would be B. All right, so this is another one that is going to be an example like the one I did. So I want you to try to do this problem on your own, and then we'll come back and we'll talk about it. Okay, so for this problem, again, we are to label -3, -2 as B. Point A is 3, 2. And then we're going to go ahead and calculate the slope. So the slope of this line is this rise value right here. And it appears that that value is 4. And the run value looks to be 6. So our slope, or our rise over run, would be 4 over 6. When we reduce that, we get 2 over 3. And as I read this line, it's going up, therefore it's a positive slope. So to get our other point that is on that line, we would start at either A or B. And we want to rise 2 So let's take this one, rise 2, run 3. So it appears to be that our point that is on that line is at point 0, 0, or the origin. Next, the last two examples have to do with looking at and interpreting drawings. So one thing I want you to understand here is, remember 3 points are needed to talk about a plane. So if I looked at this plane here, S, so this S, that's a plane for sure. But then we kind of have this plane right here that's connecting A, B, C, and D. So it appears that all of these are on the same line. So there would be like if you could think of a piece of paper cutting through, and the line where they cut through, where they have like the floor versus the ceiling, would be, or the wall versus the floor, would be this line BC. So in this case, the number of planes in this figure would be, first of all, plane S, and the one also that contains A, B, C, and D. So there'd be 2 planes. Name 3 points that are collinear. So again, collinear means that they are going to be on the same line, and our only choices for that would be points A, point B, and point D. So they want us to know if A, B, C, and D are coplanar, and to explain. They would be on the same plane, so yes, because we need 3 points that are non-collinear, make a plane. So in part D, at what point do DB, so line DB, and line CA, at what point do they intersect? So at the intersection point, it appears to be at that point, and that would be your point A. This next one is for you to pause the video and work this one out. We'll come together and work out the problems in just a moment. Okay, so this example is pretty much similar to the one that we just went through. There's 2 planes. The points that are collinear are A, B, and D. And then it asks if A, B, C, and D are coplanar. We can say yes, because the 3 points are non-collinear, make a plane. And at what point do lines DB and CA intersect? And that again would be point A. So that is the end of the video for today. You will just have some time in class then to work on some examples and ask questions. Bye for now.